your Algebra 2 Semester 2 final review packet and how to go through each problem step by step. First problem, graphing an exponential function. And with any graphing, you always want to make a t-chart, plug in some numbers. I chose between -3 all the way up to 3. So take a graphing calculator, you see your e to the x button down here, so second e to the, and we'll start with the -3, and then we subtract 2 afterwards to get -1.95. And you're going to keep going, plugging those numbers in. Take 1.63, -1, 0.72, 5.39, 18.08. You're going to graph those numbers. So -3, -1.95, -2, -1.86, -1, -1.63, 0, -1, 1.72, to 5.39, so we got up to 5.39, and 3 gets really high, 18.08. So you should get a graph that looks like this. And what you're going to find with any exponential function, you're going to have what's called an asymptote. This is going to be a horizontal asymptote at the point y equals -2, because this line approaches but never crosses y equals -2. With the natural log, this is an inverse function of your exponential, but the same thing. You want to try some different numbers. If you tried 0, for instance, and you tried to take ln of -3, because 0 minus 3 is -3, you get a non-real answer. If you do anything up to 3, like the natural log of 3 minus 3 or 0, you still don't get a real answer. The first time that you're going to get a natural log is of 1, and you get 0. So how do we make a 1 here? Well, I got to put a 4 in. So I know 4, 5, and 6. If I put a 4 in, that's natural log of 1, and we found out that that was 0. The natural log of 5 minus 3, if I put the 5 in here, would be 2. So I get a 0.69. If I take the natural log of 6 minus 3, or 3, I get a 1.09, or 1.10. And if I put a 7 in, I get a 1.94. So I get 40, 5.69, 6, 1.10, 7, 1.94. So it looks like I'm going to do this. That's not my entire graph, but I do know that I can't cross this line because that makes this 0, and there's no such thing as a natural log of 0 or of a negative number. So we'll start approaching 3 but not crossing it, meaning we'll put in a 3.5 or a 3.2 or 3.1. So if I take the natural log of 3.5 minus 3, or 0.5, I get -0.69. Or the natural log of 3.2 minus 3, or 0.2, I get -1.6. If I do a 3.1, I get a -2.30. So you end up getting a line that approaches 3 but never crosses it. That means you have an asymptote at x equals 2. For number 4, they're asking you what each thing does to your function if your original parent function is e to the x. The negative is a reflection across the x-axis, meaning it flips it down. The 1/2 is a vertical compression because it's multiplying to the entire equation, not just to the x. The -3 up there is a shift 3 to the right. And that 5 on the outside is a vertical shift 5 up. Right. Number 5, you're taking log base 3 of x plus 5 equals 2. Remember that with logs are exponents, so the log base b of a equals x. That means that if this is the base, this is the exponent, then you have a base to the exponent equals whatever else is left, which is your a. So if I do that here, that's 3 squared equals x plus 5. So x equals 9 minus 5, or x equals 4. Number 6, natural log of 7 minus natural log of x squared equals 2. If I have two logs of the same base, in which case this is e, you will take the first over the second. That's what you do when you subtract. Combine them within the same logarithm. You know that the natural log is the same thing as a log base e, meaning I can do the same thing I did up here. E to the second equals 7 over x squared. Got to clear that x squared by multiplying to both sides. So 7 equals e squared x squared. E is the same thing as a number. So if I have my calculator, e squared is 7.39 or 7.4. So this is 7 over 7.4 x squared, which equals 0.95. And I have to take the square root at the end to get my answer. The square root of my answer is 0.97. And that's number 7 is similar, except it's a plus instead of a minus. Of course, the opposite of dividing is multiplying. So you're going to turn this into 2 times x plus 9, all within the same log. This comes over here, so that becomes 5 squared equals, I distribute, this is 2x plus 18. 2x equals, 5 squared is 25, minus 18 is 7. Divide both sides by 2, you get 3.5. Number 8. If f of x equals x squared minus 25 over x squared plus 8x plus 15, and they ask you to simplify, the first thing you do is factor. So you have x plus 5, x minus 5 on top, and x plus 5, x plus 3 down here. List your restrictions. So x cannot equal anything that makes the bottom 0. So in this case, a negative 5 or a negative 3 will make the bottom 0. These 5's cancel out. So this is x minus 5 over x plus 3 with the restriction that x cannot equal negative 5 or negative 3. Number 9, g of a equals a squared minus 16 over a divided by a squared minus a minus 12 over a squared plus 3a. You, again, want to factor a plus 4, a minus 4. The division causes this to flip. So I'm going to multiply a squared plus 3a factors and a out to a plus 3. This on top comes to the bottom, and that factors to a minus 4, a plus 3. A plus 3's will cancel, a's will cancel, a minus 4's will cancel. So all you have left is an a plus 4, where a does not equal 0 from here, a 4 from here, and a negative 3 from here. Number 10, a over a minus 5 plus 4 over a minus 3. In order to do this problem, you need to get a common denominator. So a minus 5 needs to come here. A minus 3 needs to be multiplied to this side. Remember, I have to multiply top and bottom because you have to multiply by a factor of 1. So this becomes a squared minus 3a. That becomes 4a minus 20. And down here, because they're the same denominator now, I can keep them all under the same fraction. Combine some like terms, you end up with a squared plus a minus 20 over a minus 3, a minus 5. On top, you will factor to a plus 5, a minus 3, or a minus 4, sorry, over a minus 3, a minus 5. Nothing cancels your restrictions. A does not equal 3 or 5. Number 11, you have x over 6 minus 3 over x, all over 1/3 plus 1 over x. Notice that we can just take each part separately, the numerator and the denominator. So if I take my numerator first, I need to get a common denominator by multiplying by 6 over 6 here, x over x here, and that gives me x squared over 6x minus 18 over 6x, so now you have a common denominator. On the bottom, this needs an x, this needs a 3. So on the bottom, I end up with 3x on the bottom, so that's x times 1 is x, plus 3 over here. When you do these, you can flip and multiply because this is division. So this is x squared minus 18, does not factor, over 6x times the inverse So 3x over x plus 3. The 3x and the 6x cancel down to a 2. Your final answer is x squared minus 18 over 2 times x plus 3. Number 12, 1/3 minus 1 over t equals 5/6. You want to clear all fractions, not just get a common denominator. So I'm going to multiply by the common denominator, which is 6t, 3, a t, and a 6. The common denominator is 6t. If I multiply it to both sides, I don't have to worry about top and bottom. When I distribute, the 6t over 3 becomes 2t. The 6 and the 3 cancel down to a 2, and there's a t left over. Over here, the t cancels, and you still have a 6. Over here, the 6's cancel, and you have 5t. Subtracting 2t from both sides gives you 3t. Dividing 3 from both sides gives you negative 2 equals t. Number 13, 3 over x minus 1 plus 5 over x plus 2 equals 5x over x squared plus x minus 2. This can factor to 5x over x minus 1, x plus 2, 5 over x plus 2. Notice that you already have x minus 1, x plus 2, so that is your common denominator. Multiplying both sides by x minus 1, x plus 2 will clear that. X minus 1, x plus 2 cancels. The x minus 1's cancel here. The x plus 2 is left over, so you have 3x plus 6. When you multiply here, the x plus 2's cancel. Multiply 5 times x minus 1 plus 5x minus 5 equals 5x. Subtracting 5x from both sides gets rid of those. So this really ends up being 3x plus 1 equals 0, or x equals negative 1. Number 14, you use the formula t over a plus t over b equals 1. A is the first person working by himself, b is the time it takes a second person alone, t is the time it takes together. So from the information given to you from the problem, t is going to equal 8, that's the time they took together, so 8 goes in for both of those t's. And they give you one other person, which is 12 hours by themselves. You clear this fraction by multiplying both sides by 12b, that's the common denominator. So we got 12b here, the 12's cancel, this is 8b, this b cancels here, so you get 96. 96 equals 4b when you subtract 8 from both sides, and 96 divided by 4 is 24 equals b. So 24 hours, it takes 24 hours. Number 15, f of x equals 1 over x minus 3 plus 2. Again, you're going to make a t-chart. Notice that you cannot have 3 here. That's kind of your boundary, because 3 is going to make that not true. So let's go above and below 3. For example, if I went 4, 5, and 6, if I plug a 4 in here, that's 1 over 1 plus 2, or 3. If I plug a 5 in, I get a 2.5. If I plug a 6 in, I get a 2.33. Notice that I'm going to start approaching something, but I'm never going to cross it. I also only start here, so I also want to get as close as 3 to possible. So if I put something in like a 3.5, then that's 1 over 1/2, or 2 plus 2 is 4. If I put in a 3.2 and a 3.1, that's actually going to get me closer and closer to 3, but never crossing it. So you have an asymptote at x equals 3. Notice that's where this comes from. And the other asymptote is the y, the 2. You start approaching 2, but you never cross it. So those are your asymptotes, y equals 2 and x equals 3. And if I start going the other way, I want to see what happens if I plug in a 2. That would give me a 1. If I plug in a 1 and put it in my calculator, it would be 1.5. If I plugged in a 0, it would be 1.67. So I would have 2, 1, 1, 1.5. And I would get really close to 3 and not touch it. And if you started putting in things like 2.5, 2.6, 2.7, you'd start to see that. Again, approaching 3 and approaching 2 on both sides.